For 12.4, we're going to go over properties of chords. To start off, just a little bit of review for vocabulary. If you have a semicircle, remember the measure of that one is 180 degrees. And then a diameter is connecting or cutting off a semicircle, and it has to go through the center. Then we have a major arc, which is more than 180 degrees. And then a minor arc, which is less than 180 degrees. Okay. And then a chord is just connecting 2 points on the circle, and it's not going through the center. If it is going through the center, then it would be a diameter. Okay. So today we're going to talk about properties of arcs. And with this, if you have a circle with two chords that are congruent to each other, so AB and CD are congruent, the arc that it cuts off are also going to be congruent to each other. So in this one, arc AB is congruent to arc CD. Looking at example 1, we can use that. This also works if you have two circles that are congruent, and we know they're congruent if the radiuses are the same. So in these two circles, JK is going to be congruent to GF. Because they're congruent, the two arcs that those cut off have to be the same. So because JK has a measure of 80 degrees, GF is also going to have a measure of 80 degrees. Then if we look at example 2, we're going to use the diagram of circle D. And if they tell us that AB is 110 degrees, because we know AB and BC are congruent, the arcs that it cuts off are also congruent, which tells us the measure of BC is also 110 degrees. On the next one, there's a little bit of a typo, so if you could change this to the measure of AC instead. So this one is using the same diagram, but different values than the first problem. So when you look at it, the measure of AB is 150 degrees. And they want us to find the measure of AC, so that's where the variable is going to go. If we look at the information we know, because these two chords are congruent, the arcs are also congruent. And going all the way around the circle has to add up to 360. So all three of these arcs we can write an equation with and putting it equal to 360. Once we have that, we can go ahead and solve for x, which is going to be the measure of arc AC, or 60 degrees in this example. The next part we're going to go over is when you have a diameter and a chord that are perpendicular. So when they're perpendicular, remember that means they meet at right angles. So if you have two chords where they are perpendicular and one of the chords is cut in half, that means the other chord that was not cut in half, so in this one SQ, is going to be a diameter. So again, that's when you have two chords and one of them is cut in half and they meet at right angles. Using that same information, if you know you have a diameter and it's perpendicular to another chord, that tells us that the segment or the chord that it's intersecting is also going to be cut in half. So in this one, DH is going to be congruent to HF. We are going to skip example 3. You won't need it on the quiz or the test or the homework, so we're just going to go ahead and skip that one. Looking at example 4, we're going to use the diagram of circle E to find the length of BD. So in this one, we have a diameter and it's perpendicular to another chord. So that means the chord is cut in half. Because we know half of it is 6, the other half would also be 6. So to find the length of BD, we're just going to add those two together. Then our final answer would be 12. Looking at example 5, we're going to use the same type of information. We have a diameter and it's perpendicular, so the chord it's intersecting gets cut in half. So because one of them is 7, they're both going to be 7. And we want to make sure we're finding the length of the segment they're asking for. So for AC, we have to add 7 plus 7. The most common mistake for this one is people will just say the length is 7 because that was the missing piece. But you want the length of the entire segment they're looking for. With these, when you have a diameter and a chord that it intersects, it not only cuts the chord in half, it also cuts the arc in half. So those two arcs that are formed are going to be congruent to each other as well. So in this one, CD, that arc, is going to be congruent to DE. Then you can set up your equation and solve for x. So we're going to add x on both sides to get 10x equals 80. Divide by 10. That tells us x is 8. Once we know what x is, we're able to solve for the arcs they're looking for. So to find CD, that one was originally 9x, or 9 times 8, which will be 72 degrees. Then for DE, if we solved correctly for x, it should equal the same thing. And in this one, it does, because they're both 72. And then for CE, it's going the entire length. So to find that, we're going to add those two arcs together, or you can multiply it by 2 to get 144 degrees. Our last piece of information for this one is that in the same circle or in congruent circles, two chords are going to be congruent to each other if they're the same distance from the center. So if you look at this, if FE is congruent to EG, that means the two chords are going to be congruent to each other. So AB would be congruent to CD. So if they're the same distance from the center, then the chords themselves are equal to each other, or congruent. So looking at our last example, in circle C, they said that QR is equal to ST, which is equal to 16. So since we know that these two chords are congruent to each other and they're in the same circle, that means they have to be the same distance from the center. So in this one, UC is going to be congruent to CV. That gives us enough information to solve for x and then to answer our question. So we're going to have 2x equals 5x minus 9. And you want to be careful when you're solving these. You want to make sure you are carrying your negatives with it. So we get negative 3x equals negative 9. And then when we divide by negative 3, it comes out to be a positive value. Then we're going to go back and make sure we answer the question they're asking. So to find the length of CU, that was originally equal to 2x. So we're going to have 2 times 3, and that will give us our final answer of 6.